Welcome back. In my previous video I have defined what is the Banach space and some property on Banach space. Today I will discuss at first what is the bounded linear operator, and I will say what is the relation bounded linear operator in Banach space. First I will say what is the linear operator. Consider x with norm x and y with norm y be two norm space. Consider there exists a mapping T from x to y, which is linear if T of x plus y equal to Tx plus Ty and T of lambda x equal to lambda times Tx, where for all xy belongs to vector space capital X. Okay? Here mapping is such type, here the space X with norm X, norm of X, to codomain is Y with norm Y, and here the mapping is T. And what is the bounded linear operator? Bounded linear operator is linear operator T from x to y which is continuous, and if for all c greater than 0 and for all x in the space capital X such that norm Tx with respect to the norm space x less than equal to c times norm of x with respect to the norm space y, then if this relation hold, then we can tell this operator T is bounded linear operator. Obviously this operator is linear and continuous, where these two space be two norm space. If this condition hold, then T is called bounded linear operator, and the picture would be such type. Consider here the domain with x with respect to the norm space x, and here the codomain y with respect to the norm y, and consider one arbitrary vector x, and here since here norm, that means here the vector is measured by length with respect to the norm space x, and here the mapping T, and here the vector is by mapping, this is the Tx, and since here norm, so this vector is measured by T of x with respect to the norm y. Now norm Tx with respect to the norm y over norm of x with respect to the norm space x, obviously this is be a number where x belongs to x and x not equal to 0. Consider supremum of this set, obviously this is number, and this consider this is norm T, and if this number is less than infinity, then obviously the T is bounded. I hope my all viewers have understood clearly what is the actual bounded linear operator in non-linear space. Okay? If this condition hold, then T is called bounded linear operator, and the picture would be such type. Consider here the domain with x with respect to the norm space x, and here the codomain y with respect to the norm y, and consider one arbitrary vector x, and here since here norm, that means here the vector is measured by length with respect to the norm space x, and here the mapping T, and here the vector is by mapping, this is the Tx, and since here norm, so this vector is measured by T of x with respect to the norm y. Now norm Tx with respect to the norm y over norm of x with respect to the norm space x, obviously this is be a number where x belongs to x and x not equal to 0. Consider supremum of this set, obviously this is number, and this consider this is norm t. And if this number is less than infinity, then obviously the t is bounded. I hope my all viewers have understood clearly what is the actual bounded linear operator in non-linear space. Okay? Consider the identity operator and consider the space map is V to W, which is both Banach space. That means the mapping is such type map W to W, and since here the identity operator, that means here F map to F, then norm of identity operator, norm of identity with respect to the W equal to actually supremum norm of F equal to 1, identity norm of identity F. This is actually supremum norm of F equal to 1. This is norm of F and this value is actually 1. And since this value is finite number, so obviously identity operator is a bounded operator. I hope my all viewers have understood till now what is the bounded operator. Next example, consider W equal to C01, which is actually set of continuous function over the interval close 0, 1. Now consider one mapping f from 0, 1 to complex numbers C such that f is continuous, and consider the norm sup norm. We all of us know in this norm, this space C01 always complete metric space. That means this is Banach space. If we consider C101, obviously this is subset of C001. Therefore, obviously this is norm space and this is Banach space. Now consider one mapping T from C101 to C001 such that F map to F prime. For this, consider one sequence fnx equal to sine 2 pi nx. Okay? Therefore, norm of f with respect to sup norm in the interval close 0, 1, this supremum value is 1, and norm of TFN, since TFN means derivative of this fnx, therefore this is actually 2 pi n cos 2 pi nx. Okay, and norm of TFN with respect to sup norm, this value would be 2 pi n. Therefore, supremum f belongs to, here the domain is C101, norm TFN with respect to sup norm over norm Fn with respect to sup norm, this value would be 2 pi n over 1. That means this value equal to 2 pi n, and as n tends to infinity, this value tends to infinity. Therefore, this value not be a finite number. So, obviously, this mapping is not bounded operator. I hope my all viewers have understood this. Now consider one linear operator T from C01 to C01, who is given by T of fx equal to integration 0 to 1 k of xy f of y dy, where k belongs to C01 cross C01. We have to prove this is be a bounded linear operator. Here f belongs to C01 and obviously here the norm is sup norm. This is bounded operator because Here t of fx equal to integration 0 to 1 kxy f of y dy, where for all x belongs to 0 1. Then absolute value of t of fx equal to absolute value of integration 0 to 1 kxy f of y dy. Obviously this absolute value we can write this is less than equal to. We can write this is less than equal to integration 0 to 1 absolute value of kxy absolute value of f of y dy, and obviously this f of y obviously less than equal to norm f infinity, and this is less than equal to k infinity integration 0 to 1 dy. Therefore obviously this is less than equal to f infinity and k infinity, and this is true for all x. Therefore norm t f infinity less than equal to norm f infinity norm k infinity. So obviously this is be the bounded operator with constant infinity norm. Okay. Today I will stop here. I hope my all viewers have understood what is the bounded linear operator. In my next video, I will discuss some property of bounded linear operator, because this topic is very important for higher study. Okay? See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.